Hey folks, Matthew Lanigan here with BayWa RE. We're just going to give it another minute, just see people signing in, and we'll be back with you in 1 or 2 minutes and get started. Thanks. Hi folks, Matthew Lanigan here again with BayWa RE. I am the Chief Commercial Officer here for BayWa in Canada. Really appreciate y'all taking some time to spend with us and APsystems to learn a little more about their DS3 and QT2 products. APS has been a fantastic partner of BayWa's. We've been dealing with them for 9, almost 10 years now. Couple of housekeeping notes before we get going. This webinar will be recorded. It will be on our YouTube channel. If you haven't signed up already, we'd really appreciate it if you did. You'll be able to find this webinar on there as well as all past webinars. We'll also put it out on our monthly newsletter as well, so you can watch out for it there. We will be taking questions. You can just put them into the bottom right corner. We'll do our best to answer them on the fly. Continuing education is very important to BayWa. We work at it very hard with our internal staff, and we're happy to be able to share it externally as well with our customer base. Just want to do a quick test before we introduce APsystems. If I could have somebody just say hello in the chat box, that would be great. And I see Jeremy has already done that because he knew I was going to ask that, so that's tremendous. So without further ado, I'd like to introduce Derek Gerdts, APsystems Technical Support Specialist. Derek?
Awesome. Yeah, thank you for that that kind introduction, Matt. Yeah, as mentioned, I'm going to go ahead and show my screen here. All right, I think that's coming through for you guys now. So go ahead and jump into this. As mentioned, my name is Derek Gerdts. I am a technical support specialist. I cover the Canadian market and also the United States market. I've been with APsystems for about 3 years now. My main role here at APsystems is more or less providing technical support. If you ever do call the 1-800 number, I am one of the agents that do answer that phone. And I also respond to the email tickets that get written in as well. If you ever do need to contact myself, I did put the email here, the support.canada@apsystems.com. You can also give us a call on our support line, and I maybe should have added that number here, but if needed, that number is 844-666-7035. Could be found on our website as well, and figure that support channel or that phone number is available from 8 a.m. Eastern to 8 p.m. Eastern time, Monday through Friday. And wanted to briefly go over the agenda for this particular webinar. We're going to talk about the company overview, let you guys know how APsystems came about. We'll go into some of those product offerings that Matt was talking about with regards to the DS3 and the QT2. We'll go over some brief system architecture with both of those products. We'll talk about some of the resources that we have, whether it be through our website or for future webinars if needed. I'm also going to do an EMA walkthrough, which the EMA is going to be where all the information from the microinverters goes to. So I'll kind of show you what it looks like as a finished product. Hopefully show you some tips and tricks there too for some of the people on the call that maybe do install our products currently. And figure, as Matt was saying as well, feel free to answer or ask questions anytime throughout the webinar. I'm willing to stop the webinar, answer that question, or if you'd rather wait till the end, either way, just feel free to ask them as needed. So jumping right into it, who is APsystems? So APsystems is more or less a provider of MLPE, module level power electronics. We have been around since, or basically set up our headquarters in 2010 in Jiaxing, as you can see over here. Let me go back one, don't know why that went there. We are considered to be the #1 multi-module microinverter provider. We have had more than 230,000 APsystems microinverters installed in 100 different countries throughout the world. So we have a good amount of products out there that are on and working currently. A lot of data always coming back to us from those products to try and make things better in the future too. Not sure if anybody on this call has used some of our rapid shutdown devices, but we also do, besides the microinverters, have rapid shutdown units as well. Those are going to be for more so string inverter systems, but some people know us as just a rapid shutdown device and didn't know we did microinverters, or some people know us as microinverters but didn't know we did rapid shutdowns. So I figure we do a couple of different products, but those are going to be the main two. And where are we located throughout the world? I do like this map here. It kind of gives you a good understanding that we are a global company. In this particular section, like I was talking about here in the North American continent, I do cover the Canadian market and also the US market. So figure it's almost like these are individual branches here, so to say, but we do have locations spread throughout the world. So if you ever are, say, installing a product in Mexico, Brazil, or anything, figure you could use us as well. And how did we get to this point with APsystems? Figure, like I was talking about, we had our headquarters set up in 2010. We had some R&D type situations going on there for a little bit. And then 2012, we opened up our first office here in the North American continent. That was in Seattle. That covered both the Canadian and US side of things. And then at that point, we released our YC200 microinverter, followed by the YC500 microinverter, and so on and so forth. But this kind of just gives you a little bit of a timeline here of kind of how we came about and where we are today. So a lot of good information there. And jumping into the bulk of the presentation here. So just wanted to kind of point out for anybody on the call that might not have used microinverters to this point, or maybe is strictly doing string inverters. Just wanted to point out the slight differences between those two setups. So this first slide here is just going to show a traditional string inverter with or without optimizers. Figure these are going to be your modules here. You're going to have your panels basically sending all of their power down to the centralized string inverter. That string inverter is going to make that conversion from DC to AC and then basically send that to the house to be used or back to the grid for credits. So figure you're gonna have all your modules up there on the roof, sending everything down to a centralized location that then makes that conversion, and then so on and so forth. The difference with microinverters is that that conversion that happens from DC to AC is going to be taking place at the panel level, so to say. And specifically with the APsystems microinverters, figure you're going to have one module, two module plugged into just one of those microinverters. Same thing here, module, figure two modules for each microinverter. And like I said, only real difference there is just going to be that that conversion takes place at the panel level rather than at a centralized location. And jumping right into our residential product offering, which is called the DS3. The DS3 is going to connect with two PV modules, and that's for a quicker installation rather than just doing one-to-one. It can be used in a 240, which is a normal residential configuration, or a 208, configuration as well. There are some commercial sites out there that use that 208. I figure this DS3 could be used in that configuration as well. They are designed for today's high capacity PV modules. We will go over that a little bit coming up here in the future slides, talking about the max modules that you could team up with the different DS3s that we have out there. With this particular product, it is encrypted with a high-speed Zigbee wireless, what I call a TI Karamba chip. It's got some new cooling topology for advanced heat mitigation, 20% fewer components when comparing it to the YC600, which is the previous product that we had, the dual module microinverter. For higher reliability, I figure out of the box, it's gonna have a 10-year warranty for the DS3, but you can also extend that up to 25 years by doing that optional extended warranty option. Figure it is going to be UL 1741 SA and SB certified, quite a few other certifications with it as well. If you ever are interested or need a specific one, you can always go to our website and find the specific certifications that you might need for that. And I was talking a little bit about it previously with that 20% fewer components part, but I just wanted to kind of show you how we got to this point. Figure the first dual module microinverter that we had was called the YC500. That was released in 2012. The second generation of the dual module microinverter was the YC600. That was released in 2017. And then here we are today with the DS3. Figure there's 3 different models, as you can see on there: the DS3S, the DS3L, and just called DS3. You're going to see that it's more or less the same microinverter. So if you take a look at the S, take a look at the L, take a look at just the DS3, it's basically the same exact product, but the only difference between the 3 different models is going to be down here, which is the output capabilities of the 3 different models. So figure the DS3S has a capable of 640 watts AC output. The DS3L is going to have 768 watt output, and then the DS3 is going to have 880 watt output. Figure you just want to take that number, so figure 640, divide it by 2, because you're going to have 2 modules for each microinverter. That's going to give you 320 watts, which is going to be the maximum that each individual channel can output. So figure DS3S, 320 watts per module. DS3L, I think that comes out to 384 watts per module. And then the DS3 is going to be 440 watts per module. And what does DS3 stand for? So for the D in DS3, it's going to stand for dual input, meaning 2 modules per microinverter. The S is going to stand for split phase, aka single phase, which is the configurations that we use here in North America. And then also the 3rd generation of the dual panel microinverter. And just a little bit more details about each of those individual models. So figure like I was talking about with the DS3S, that comes out to 640 watts per microinverter or 320 watts per channel. We're going to recommend to use PV modules up to 400 watts with that particular model. I will say that I would probably recommend to go a little bit below that. Like I was talking about, 320 watts is going to be the max. So if you do use, let's just say, a 400 watt panel, odds are that panel is going to be able to produce a little bit more than what the microinverter is, but we do want it to be that way, but maybe just not as extreme in this situation. I might recommend modules closer to like 375 would be like a max for the DS3S. But figure if you do have any questions about that, you can always reach out to us. But going into the DS3L, there's a specific line on here that I'll talk about, but we're talking when you're sizing up the modules with these microinverters, you basically want to be at about a 1.25 ratio, meaning that it's a give or take about a little bit higher than what the microinverter is capable of doing. Reasons for that is obviously a module degradation, also to the ratings on the modules. For example, if you have a 400 watt module, the odds of it actually getting to 400 watts are a little bit few and far between. So we take that into consideration as well. So when we're trying to tell people which modules to pair with these microinverters, we typically say do about a 1.25 ratio. But just further talking about that DS3L, figure kind of how we came to the conclusion of making this particular product. Here in North America, most people that we're installing systems for are going to be having 40 amps of available service on their panel, which basically comes out to 2 strings that you could make on 20 amp breakers. You're looking at a 16 amp max load on a 20 amp breaker per NEC code. That's going to leave you with about 5 microinverters per string. Comes out to 3.2 amps per micro. So if you just do that calculation there, 3.2 times 240 comes out to 768, or about 384 watts per channel. So kind of just wanted to call out there and let you guys know how we came to that calculation if you do want to use that. And then figure for the last one here, the DS3, that 880 watt one, we do recommend modules up to about 460 watts. I would actually say that that's a pretty good round number there. 460 compared to the microinverter being able to make 440, that's probably about right. You could even probably go up a little bit higher if you wanted to. And also wanted to show on the data sheet, if you're ever looking to, figure out how to set these particular units up, the data sheet does have a lot of good information on here. A couple of things that I will call out, which is actually a difference between the YC600 and the DS3 here is going to be that there's a couple options for breakers. On the YC600, you had just a 20 amp branch that you could set up. On these DS3s, you have the option to still do that 20 amp branch, but you could also do a 30 amp branch as well. Figure if you do go up to that 30 amp branch, you'll see that you can put more microinverters on a particular circuit than if you were to go with a 20 amp branch. And so some people that works out a little bit better for them. So wanted to call that out, that figure you have 2 options. You can either go with that 20 amp or that 30 amp. And this line here is just going to tell you how many you can put per model on that 20 amp or 30 amp branch. So figure that's going to be your string setup there. If you are going to go with that 30 amp branch setup, I would recommend to use the 10 AWG wire. Don't use the 12 AWG wire. If you're going to use a 20 amp breaker, you can use either or. You could probably get away with using the 12. Some other things that I wanted to call out here on this data sheet, if you're ever looking to know if the microinverter could work under specific circumstances that you have going on there, figure it's going to tell you, the voltage range that this particular product will work under. It's going to tell you the frequency range that the product can work under. Quite a few different things on here that can let you know, will this particular microinverter work for my setup? So just kind of wanted to bring up this data sheet. It is available on our website as well if you need it, but I just wanted to call a couple of things out there. And then wanted to show you guys the DS3 microinverter accessories page as well. A lot of times when you're building a system and designing a system, you're going to need quite a few of these accessories. Pretty common one is going to be a DC extension cable. If you ever can't quite make a direct connection with the module to the microinverter, we recommend to use these DC extension cables. Also, too, you have some of these caps here. So if you ever come across a situation where you have an odd number of modules and you need to have one of those channels be capped off, you can use these DC caps. If you ever have a spot on your trunk line where the microinverter plugs in on the AC side and you have one of those connectors not in use, you can cap them off with this terminal cap. Then I specifically wanted to call out this disconnect tool. If you don't have this disconnect tool, I highly recommend that you have some. What this is meant for is to disconnect the microinverter off of that AC trunk line. We find that people that don't have this tend to use a screwdriver, and it can be extremely difficult to get it off, not to mention that it can cause damage to the micro as well. If you do have, say, troubleshooters or people that are going to do some service work on a system after it's installed and they have to take apart some microinverters to, say, find an issue, whatever the case may be, this disconnect tool can save them a lot of time. You literally just plug it right into that little slot and it comes right out. It's super simple. It sounds silly, but a lot of people don't have this and it can cause some problems for them. So just wanted to call that out as well. And this is going to be to waterproof the end of your line, which is this end cap here. So yeah, a lot of accessories there. And just wanted to briefly show what a typical, say, cabling guide would look like for the DS3 product. There's a couple of different configurations here. Obviously, you have 2 modules sitting horizontally, some doing vertically, all in one row and separate rows. So figure the lines that are showing on here is basically the DC connections that are getting plugged into the microinverter. So just kind of showing you a couple of different options and what it would look like. Figure in this situation, you have a pretty long connector here going from the panel to the microinverter. Those red lines are going to indicate a DC extension being needed in that situation. So figure a lot of different scenarios you can come across when you're installing these particular products, and this is just a couple of here to kind of show you how it would work plugging in those modules to the microinverter. And I wanted to call out a couple of proper and improper installation techniques. I added 3 photos on here. 2 of these are going to be improper installation techniques, and one of them is going to be a proper installation technique. If you take a look here, figure this one, it's close to being proper, but it's not quite. In this situation, you can tell that that microinverter is installed directly onto the racking system, which is the way that we want it to go, but it pushed up almost, basically touching that module there. That is not something that we want to see, because we're going to want at least usually about 1 centimeter or more of heat dissipation to allow for heat dissipation to happen under this situation. So we would recommend to move that in this particular picture here, install that microinverter just slightly lower, not have it pushing up against that module. That can cause damage to the module, can potentially cause damage to the microinverter, so we don't want to see that. This particular one is also an improper installation technique. Figure it was put onto the racking correctly. You do have good heat dissipation there, but it is exposed to all elements. If you were to go through and check out our installation manual, you will see on there that they are required to be within warranty to not be exposed to the elements, like this particular one is. So figure if they just had it sitting underneath that panel rather than to the side of it, that would be a lot better in this situation. And then this third picture here is a proper installation technique. You have good heat dissipation. It's not right up against the module. It is installed directly onto the racking. I maybe would like to see those wires maybe not quite doing a almost 90 degree angle there, but ultimately I wouldn't have a problem with this, and this would be technically considered good and within warranty. And so then I wanted to make a slight pivot here to mention how all that microinverter, once it gets installed, where does it send all of its data to, so that someone like myself, a technical support specialist, or say someone like your customer, or even you as an installer, you'll know what's going on with each individual microinverter that's up there on the roof. Obviously, this is going to be our solution there, which is called an ECUR, R standing for residential. Basically what an ECUR is it's information gateway for solar microinverter array. So all that means is that the microinverters are pulled on a 5-minute consistency basis throughout the day. It is taking all of its information and sending it to this particular ECUR. And that ECUR is then sending that information to our cloud, which then updates the desktop version of our monitoring portal or the customer's app that they can take a look at and see what their system's doing. So figure that's what this particular part here, the ECUR, is doing. And figure you can set it up. It does have to be set up to the internet in order to, say, update the customer's app or update the monitoring portal. And figure to get it connected on the internet, you can do it via Wi-Fi or Ethernet, but it would have to get connected to the customer's internet in that situation. Or you could go with the cell option too, which if you ever did have a question about that, feel free to let us know. We do have a couple options there. And how does this particular unit work? So figure just like I was talking about, but this is a little bit of a better visual here. You have your modules, they're basically doing their thing, and the microinverter is making that conversion. And then figure any of the data, whether it be DC volts, current, AC voltage, temperature, quite a bit of different information that the microinverter can get. It is then taking that information and sending it wirelessly to this ECUR, and figure this one antenna here is going to be the part that's communicating with this little antenna on the microinverter. So those are the 2 parts talking with each other, exchanging that information. So it sends it here. This thing accepts it, uses the internet to then upload it to our servers, which then turn around and update the customer's app or the desktop version of our monitoring portal. And like I was talking about, this is called the EMA, which would be the monitoring portal, desktop version of the monitoring portal. It's a system monitoring interface. It operates 24/7. You can view it online on a desktop computer, or you can do it through the app as well. And it can detect and alert users to any performance issues, gives you module level monitoring. It's a good diagnostic tool. Post PTO or post when the system's turned on, it can let you know if you have a bad panel or maybe have a bad microinverter or whatever the case may be. And I'll be doing an EMA walkthrough here, maybe about 10-15 minutes or so, like I was talking about at the beginning. So I'll show you what that looks like. And then figure this is something new that we've had maybe for about a year and a half now. So I guess it's not too new anymore, but still, figure you're gonna have everything on the desktop version of the EMA is gonna be now in the EMA Manager app. So you are free to download this on the Google Play or Apple App Store. It is free, doesn't cost anything. And figure everything that you could get online on the desktop version is more or less now in this app. You can check on customers' system production, check individual, say, voltages, current, temperature on an individual microinverter on a customer site. It can be a good troubleshooting tool for any techs that you have going out into the field. Quite a few different things. You can also create sites from this app as well, like create an actual monitoring account from scratch. Yeah, quite a bit of different stuff in there. Then we're going to segue back and talk about the QT2 now, which is the APsystems commercial solution. So figure the QT2 is a newer product for us. It's been released, I want to say, give or take, for about a year now, although I want to say we haven't had installations take place maybe for about the past 6 to 8 months or so. So it's a fairly new product for us, but figure I like this map here, or this picture that it's showing on this particular slide, because it just likes to show that it's more or less how you install these things is extremely similar to how you would do a residential setup. Obviously, you have different, number of microinverters per string, maybe using a different breaker size, maybe having to use some different components. But as far as installing the product itself, it's going to be installed underneath, a module. You're going to connect your modules to the microinverter, and you can basically use so many per string. All that information gets sent to our ECUs. So it's like a residential installer looking to maybe make a switch to commercial. You'll find that a lot of the best practices with installing this QT2 are very similar to doing a residential installation as well. And figure the one difference on here is going to be that there's this secondary ECU, which is called an ECU-C. Oop, didn't mean to do that. But called ECU-C instead of ECU-R. Figure ECU-R, that R stands for residential, ECU-C, the C standing for commercial. The only real difference between this ECU-C and the ECU-R is going to be that the ECU-C for commercial has the capability to do consumption level monitoring. You would have to install some CTs to get that, but figure that is literally the only difference. If you didn't have CTs installed with this ECU-C, then the data that you're getting back from this would be the exact same thing as the ECU-R. So if you need that consumption level monitoring for the commercial system, figure definitely want to go with the ECU-C to get that data. If you don't need it, then figure the ECU-R would suffice just fine. And figure there's going to be two different options for the QT2. There's going to be the 208 volt configuration or the 480 volt configuration. Very similar, but you can tell that there's a slight difference with output. The 208 is going to come out to 1,728 for the whole microinverter, and the 480 is going to be 1,800 watts for that particular microinverter. And as you can tell on here, the difference between the DS3, which was our residential product, is you have 1, 2, 3, 4. You're going to have 4 modules be plugged into one microinverter. So this is going to be what we call a quad microinverter. So it can help you install a little bit quicker, because figure 4 modules per microinverter leaves you with less connection points that you have to make throughout the line. So hopefully that'll help out some of the commercial installers out there. But figure in order to get that module maximum output number, you're just going to want to take this, say 1728, divide it by 4, and that's going to give you the maximum of each individual module and what it can output. So for the 208, it would come out to 432 watts is about the maximum that each individual channel can make on this microinverter. And then for the 481, that's going to come out to 450 watts that it can do per individual mic or per individual panel on the microinverter. It is native three-phase. Yes, sir.
Oh, sorry, we've got a couple of questions.
Okay.
Is the new QT2 5-pin cable compatible with the QT2 3-pin inverters, or do we need to ensure we have a QT2 5-pin inverter as well?
So it's a pretty good question, and something that is being discussed currently, and I'm not sure if I have an exact answer for it. My understanding is the first product that was released was a 3-pin, and we are now switching to a 5-pin. Beyond that, as far as would it work, we have many 3-pin installations out there that are working pretty well. Where my mind goes, and this is the part that I'm not entirely sure on, so I'm just going to be honest here, is like, let's say, for example, if you ever have like a warranties type of situation, I don't quite know what's going to happen with the 3-pin compared to the 5-wire, but I will say that currently speaking, we are making a shift to 5-wire.
Great. And one other, just to be clear, can the ECUR be used with the QT2 regardless of voltage at site? So as long as consumption monitoring is not needed.
Yep, exactly. Figure definitely with a QT2, you can use the ECUR. If you don't need consumption level monitoring, I would highly recommend that you use the ECUR. It's I'd say a cheaper option to go with. You're going to get the same exact information as the ECUC. Shouldn't matter with the voltages, not that I'm aware of. I haven't come across a situation where that affected anything. So figure, yeah, if you're going to use the QT2 and you don't need consumption monitoring, I would highly recommend to use the ECUR.
Great. And one last one, does the ECUC include any CTs, or do they need to buy CTs separately?
Good question. They do have to buy them separately. Figure ECUC is just going to be sold by itself. And then at that point, if you did want to get the consumption monitoring, you would have to further or make an additional purchase for the CTs. I will say that according to our user manual, it does require for the CTs to be APsystems branded CTs. I will say though, just being honest here, I have had other installers use non-branded APsystems CTs and they did work. But if you want to be, say, within warranty, so that if there was ever a situation where maybe something needed to get RMA'd or whatever, I would highly recommend to go with the APsystems branded CTs. They tend to work the best.
Great, thank you.
Yeah, no problem. So I'm going to go ahead and continue on here. Like I was talking about, you have the native 3-phase. You're going to have line 1, line 2, line 3. It connects up to 4 PV modules. It is UL 1741 SA certified. There's some additional certifications with there. I don't think the slide's been quite updated since, but if you ever do need a specific certification, just let us know, or also check on our website. There's a lot of certifications listed there as well. And one of the main one of the main features here is that it is rapid shutdown compliant, so you don't have to put any additional rapid shutdown units in per module. So hopefully that'll help lower the costs somewhat for you too. So figure it is rapid shutdown compliant, don't need any additional things there. And then talking about some of the benefits there, you're going to have all the benefits of module level power electronics for commercial 3-phase system. Like I was talking about, rapid shutdown compliant, could lead to lower cost of energy over the life of the system. You got not necessarily so high voltages up there on the roof. I was talking about specifically with safety. It can accommodate today's high capacity PV modules. Usually we say try to stay between 400 and 600 watts on those particular PV modules. They can pair with a whole different a lot of different modules with 60, 72 cell, 96 cell, split cell, half cell, bifacial. We do have an APsystems module compatibility calculator. So if you're ever interested in saying or checking to see if your module is compatible with which of our products, go to our website, go to the library. There's a module compatibility calculator where you input all of, like, say, the ISCs, the voltages of the module, temperature coefficients, all of that stuff, and it'll let you know, spit out an equation at the end and say, yeah, DS3 will work with this module, QT2 will work with this module, or no, it won't work. So if you ever have a question or wanting to know, figure use that module compatibility calculator. Should hopefully be a good tool for you. Figure it also still has that encrypted 2.4 gigahertz Zigbee wireless chip in there. And then we were just talking about the ECUs a little bit. So figure you want to be within about 250 feet microinverter to ECU in order for the ECU to be able to pick up that communication from the microinverters. And some things can limit that a little bit, whether you're going through walls or trying to go through metal. Sometimes that can throw the Zigbee signal for a loop, but figure straight line of sight, give or take about 250 feet.
And we have one more question here, Derek. Okay. Sorry, too. We have a client with YC500 micros that wants to expand his system. Can we use DS3S and add the original site monitoring? Or if we install a new ECUR, will the YC500s connect to it?
Yeah, another good question there. So figure when we made that switch from YC500 to the YC600 products, we went with a different form of communication and also a different AC connector. So my answer is that you can definitely do it, but figure it's almost like you're going to have two separate systems. You won't be able to add the DS3s onto the same AC line as the YC500 product because they're going to have different AC connectors. And also, two, the ECU3 is not going to be able to communicate with the DS3 microinverter. So the ECU3 was the ECU prior to the ECUR, and that one paired up with the YC500 product, and that's a PLC communication. The DS3s are going to be Zigbee wireless communication, so it is different methods. So figure it's basically not compatible. You can definitely do it and add to their system, but figure you're going to have a new run a new circuit with the AC connector. Is going to have to get a new ECUR. So it's possible, but if you were thinking of just, like, say, going on to the existing circuit and just adding a couple of DS3s on there, pairing it up with that ECU that's already there, I will say that probably wouldn't be the best scenario to do it that way, because figure it won't be able to communicate with that ECU that's already there. And then figure those DS3s won't be able to plug into that AC circuit either, just because it's different connectors. So figure if you run a different circuit, get a different ECUR, it's definitely possible. But if you were thinking of hopefully a quick fix, it's probably not that either. So hopefully that helps answer that question.
Thank you. And one more, can I use the ECUC on a residential 240 volt system to get consumption monitoring?
So my understanding is that it's not intended to do that. I will say that I've had other people configure it in a way in which it was possible, but it's not something that is listed on our data sheets, our installation manual. It basically says that it has to be for a commercial 3-phase configuration in order to do that. So I'll say, just to answer the question, is negative. I wouldn't use it in a normal residential configuration.
Thank you.
And then just calling out a couple of things here on this QT2 data sheet. Same sort of situation as the DS3 data sheet if you're ever looking to see how many you can put on a particular circuit. This particular one does not give you the option for the 20 amp branch. It's just a 30 amp branch. So figure if you're going to be installing this QT2, you can either go with the 208 volt version, which is going to give you 5 per circuit, or if you're going to go with the 480 version, you can do 11 per circuit. Same sort of situation here. So if you're just going to want to use the 10 AWG wire, it's going to give you the ranges here, voltage ranges that it'll operate within, voltage range that it'll operate within, even frequencies as well. It's going to let you know, and I actually didn't call this out on the DS3 data sheet, but on this particular part, you're going to see 2 different ranges here. These 2. It's going to show you the operating voltage range and the peak power tracking voltage. So figure the difference between these 2 columns is going to be the QT2 can operate with modules that are in between this voltage range, 26 to 60. But what we recommend, highly recommend, is to stay within 30 to 45. It's almost like hitting the sweet spot. If you ever play golf or play baseball, you know, if you like top something, it's like you basically just want to be in this sweet spot here between 30 and 45, and that's going to make be the most efficient way for these things to operate and give you the most production out of it. And the most efficient manner is going to be between that 30 and 45 mark. So figure it can operate within 20 to 60, but I highly recommend, because once you get out of this 30 to 45 range, it can be a little bit wonky. So try to stay within that 30 to 45. And I'm going to go ahead and do this EMA walkthrough now. So let me close out of this real quick. It's in that there, discard. And I'm going to have to log back in here because I think it's going to log me out. Well, maybe it didn't. So I'm going to go ahead and log in as an installer. This installer is out of Florida, but I just kind of wanted to give you guys what it would look like if you were to log in. And this is going to be the desktop version of the EMA portal. So when you first log in, this is what it's going to look like. It's going to have all of your sites listed here. It's going to give you a little bit of general information, like say, you know, which customer's username. It's going to give you their ECU ID, their actual name, where the site's located at, size of the system, when they were registered. And then the important part here that I wanted to show is this traffic light, or what I call a traffic light. It's going to give you different colors here. The options are going to be either black, yellow, red, or green. Figure black is going to mean that the ECU, that communication gateway, has never communicated with our servers, so to say, so we don't have any data coming from the site. Yellow is going to mean that there's one or more microinverters on site with a problem, meaning communication or production. You could also have the red light here, which is going to mean that the ECU was connected to the internet at one point, but has since been disconnected. And then you also have green, which is going to let you know that all modules are communicating and producing normally. And so jumping into one of these sites here, this is what it looks like when you click into an individual customer's account. It's going to give you this graph, and this graph is going to let you know what today's data is. So you can tell on here the different reporting times. And you can go to any particular section here to tell you the wattage output of the entire system at that particular report time. There are also some useful bits of information here, like the ECU IDs listed, the amount of kilowatt hours the system's produced today, what the wattage output was on the last report time. They can also give you some system information here, when it was registered, size, products being used, you know, all that fun stuff. And then I'm going to go ahead and jump into this module view here. So for this particular customer, as you can tell, you got that top part of the system here. It seems like it's working fairly well. Maybe one module got a little bit of funkiness going on, but it's pretty clearly visible that there is something going on with this bottom section here. And you can also check these same sort of settings that I'm looking at now with your desktop version of the EMA portal. Why I wanted to bring up this particular site is just to show you that there's this, you know, non-working microinverters down here, and kind of where I would go check to see where the potential problem is coming from. This could help you, say, to explain to a technician prior to going to a site what they might need to check for, hopefully save them some time there on site when they need to troubleshoot. And so the first place that I always go is going to be checking, you know, do we have voltages going on the DC side and AC side? So how to do that is you can click on any one of these individual modules, and it's going to give you this detail option here. Go ahead and click that. And you got some information like the ECU ID, what microinverter number we're looking at, the data type, performance in a day, you can change it to hourly, daily, monthly, yearly, and then also the data level. And the data level is going to let you know if you're looking at the AC side or the DC side. So figure input 1 is going to be channel 1's DC side. Input 2 is going to be channel 2's, or the second module plugged into the microinverter, its DC side. Or you can go to output, which is going to give you the AC side. And then you'll see that the couple different sections that they measure on here, the things that they're giving us the data for, is going to be DCP, DCV, and DCI. If you're ever curious about what those definitions are, it's going to let you know that P stands for power, V stands for voltage, and I stands for current. So in this particular situation, looks like we have good voltage making across this particular module. I got 42 volts, which is what I would want to see. I went ahead and switched it to the second module on that microinverter. Same sort of situation. Looks like it's getting good voltages there. Obviously no current, but getting good voltages. And I'm going to go ahead and switch to the AC side now. And there's where our problem's coming from. So that particular blue line is showing me temperature of the microinverter, but I should also see an orange line showing 240 volts, give or take, AC voltage. But as you can tell in this particular one, the AC-V reading is coming through at 0. So my guess is that probably every single one of these is coming through at AC volts of 0. It was a little bit, but figure each one of those is not getting AC voltage. And if I were to go back in time, I could probably see that there was probably a breaker trip situation happen. They probably all lost AC voltage at the same time. And so if I was sending a troubleshooter out to particularly look at this site, I would say, hey, start by checking the breaker, see if that's tripped off. If not, there's something preventing AC voltage going up to that or going to that circuit. So that's where I would troubleshoot. Don't even worry about unplugging modules, whatever the case may be, just specifically check the AC side. Then if also too, if you ever did have a customer that was complaining about production or maybe complaining about bills, this is the particular section that I like to go to. Under this report section, it'll let you know if you go to the summary report, what this system has made month by month over the course of a year. It's a quick little snapshot to know if the system, is doing what it should. This is going to give you kilowatt hour output for that particular month. So like for example, last month in July, the system made 568 kilowatt hours. So this is a good little report tool to have if you ever have customers that are questioning some things. Then you also have a couple of options here too, where you can go in and do some remote control settings on these microinverters. So like for example, you can go to the switch on/off section here. If you ever had a microinverter that maybe is say not working and it ran into some sort of parameter issue, sometimes you can clear it just by doing this, selecting the microinverter that's having the problem and doing that on command. Also too, if you have say for example, maybe a system that you installed and want to put it like in a standby mode, I call it a standby mode, you can technically switch them all off. And then when the system say grants permission to operate, or you can actually turn the system back on after inspection approval, you can go through and just do a remote command and turn it back on. That would basically allow you to turn the system on remotely or off remotely, so to say. So if you ever did want to do that, that's the section there to do it. And then you can also too, and this one doesn't get looked at too often, but this diagnose tab, and then clicking that diagnose dropdown is going to allow you to see the last time that the ECU detected internet under that last heartbeat timestamp. It usually updates about every 15 minutes or so. So figure if it's not quite real time, that's okay. Just make sure that it updates about once every 15 minutes, and that'll let you know that the internet connection with that ECU is solid. And so I'm going to go ahead and go back there. And oh yeah, a couple other things here. And one last thing I wanted to show you, if you were ever interested, there's some literature when you're logged in on your installer account on this EMA desktop version of the portal. You can go to this setting page, and there's going to be a resource tab over here. And this is going to allow you to see an APsystems troubleshooting guide. So if you're ever interested and maybe see an issue going on with your site, this particular troubleshooting guide will basically allow you to see, if it's a communication issue, why is it a communication issue? What's the definition? How do I fix it? Production issue, let's say like I was talking about with this site, how there is an AC problem, it'll define it for you and tell you how to fix it. Quite a few different things on this particular troubleshooting guide, things that we would know as technical support specialists that maybe you wouldn't. Some of these things will be helpful with that, like a couple questions here about troubleshooting CTs. You can find out some of that information on here as well. A new tool that we just literally released, I want to say about a week or two ago, is going to be this AP Designer tool. I don't know too much about it, but if you click on this, you can more or less go in here, and it's going to allow you to basically enter a site address and do a drawing of the system, like say add your modules onto the roof. And then this particular design tool is going to spit out what not only maybe microinverters you need, but it's going to tell you the accessories that you need, how many, say, end caps you need, you know, more or less design an AP system for you and tell you the amount of products and accessories you're going to need. I will say that I've been messing with this thing a little bit over the past week or so, and it's a little bit buggy right now. So if you do come across some things that maybe look a little funky, figure we are working to update this, but figure it is live at this particular moment. So if you did want to use it, by all means, just let us know if you do come across something that looks a little bit funky and maybe have to do a fix. But just wanted to point out that we did just have this tool go live maybe about a week ago. And this allows you to more or less know which all products you need to complete an APsystems installation. And I'll go ahead and pull this back up and we will, from current slide. So I did the walkthrough. And if anybody is ever interested in learning further, figure we do hold monthly webinars that are specifically through APsystems. If you're ever interested, just keep an eye on our website for dates for those. Also, too, you can always go to our website. There's a lot of information there with product data sheets, user manuals, and whatnot. That'll be at canada.apsystems.com. There's a frequently asked page, a frequently asked questions page for installers and homeowners, training page as well. If you're ever looking to register as an installer, you can use that link there to do so, and you'll get yourself an installer account, which would allow you access to the EMA portal. We also have a YouTube channel, which can be found at youtube.com/APsystemsSolar. There is installation videos there, troubleshooting videos there, previous webinars we've done, quite a bit of different stuff too. And so that's basically all I had for today. I'm sure I'm probably running up close to time, I would imagine.
We have another question here. Thank you for that, Derek. Really appreciate it.
Okay.
Oh, can you share the link? Please share the link to the design tool.
Oh yeah, let's do this. And am I able to do that on the chat box? Do you happen to know? Let's see. I just did that there. I'm not sure if that came through for you or not. But figure if you do have an installer account, like say if you log into the desktop version of the portal, figure once you log in, you're gonna have, you know, this is what it'll look like here. Just at the top, it'll have an option for AP Designer, and that's the new part that I was talking about. I just sent the link there on the chat box. I don't know if we're able to distribute that to that question.
We'll get it to people for sure after the presentation.
Okay, perfect. Yeah, I figure definitely play around with that. Let us know if, like you said, something looks a little funky. It's definitely something we're hoping that will help people in the future designing commercial sites or even residential sites. Basically know, you know, what the bill of materials needs to be. That's what the goal was with it. It's probably not quite perfect right now, but hope to get it there pretty soon. So definitely, yeah, mess around with it and let us know.
Great. So I don't see anything else. So thank you, Derek. Really appreciate you taking the time, and thank you to all of our customers and friends out there who've taken the time out of your busy day. We really appreciate it. Once again, this was recorded. It will be on our YouTube channel. If you haven't signed up for it, please do. This presentation's there as well as many others. This will also go out in the newsletter next week as well. If you haven't signed up for a web shop account yet, I would highly encourage you to do so. It's really a tremendous resource. We're getting great feedback on it. Specs, pricing, inventory, install manuals. You can see all your orders in there. It's really quite a powerful tool. If you have follow-up questions, please reach out to either the inside or outside sales teams. They're well-versed in APsystems. Also, you'll have the opportunity to meet Derek in person. So we'll be doing our road shows this fall. So 2 of them coming up. Halifax, October 5th. If you haven't signed up, Atlantic Canadians, would love to have you at that show. I'm a former New Brunswicker, so I'll be there as well. So I'd love to see you all there. And we also will have a show in Edmonton on November 15th as well. So yeah, we'd love to see you folks come out and spend time with APsystems in person at one of our road shows. So thanks again, everybody. Really appreciate you taking the time. And thanks again, Derek. Really appreciate you help educate us all a bit more.
Awesome. Yeah, thank you guys too for hosting us. And yeah, if anybody's going to those shows, look forward to meeting you guys.